Welcome back. This is Discrete Optimization in Coursera, and this is not a lecture. This is about work. Okay, so what we're going to do today is basically look at the course structure and the philosophy behind the courses, what we are trying to achieve, and then give you a sense of the assignment design and what you have to do in this class to get a grade. Okay, so basically, you have seen this picture before, right? So what you have over here is problem size. You have time over there, okay? And the goal in this class is to try to get, to pull this exponential such that you can solve real practical problems, okay? So you know that the best you could ever do in these problems is typically linear time, right? It means, because that's the time that it will probably take for checking a solution, for actually outputting a solution. That's the number of decision variables. You have to decide for every one of these variables what you do, okay? And so what we want is you to design algorithm in this class such that you get close to that, as close as possible, for problems that are going to be of reasonable size. So we want to pull this exponential as closely as possible to this linear time. Of course, it's tough, okay? It's going to be really tough, okay? And so one of the things that you'll see in the class is a bunch of lectures to actually try to do that. Okay, so you'll see different techniques: constraint programming, local search, and integer programming or mixed integer programming. And they will give you the tools to actually try to pull this exponential or find high quality solution quickly. Now, if you look at these assignments and can solve them all very, very quickly, okay, there is one thing you need to know. You need to call me as quickly as possible, okay? And don't tell anyone, just talk to me, okay? And we'll be in business together. Okay, so now for the assignment, okay, so this is how it's going to work. Okay, so we're going to give you one NP hard problem every week. Okay, and so your goal is going to be to solve it, and you can solve it in any way you want. Okay, so you will use any of the techniques that we have presented. You can invent your own, but you have to optimize it as best as you can. Okay, pull this exponential, find high quality solution quickly. Okay, and then what you will have to do is to submit this solution to us such that we know how great you are and how beautiful your solutions are. Okay, so that's the rule of the game. Okay, one NP hard problem a week. Okay, and we'll start easy and then we'll move to more and more complex problems as the classes goes on. Okay, now this is how we're going to grade. You can always submit junk thing, okay, or infeasible solution, and if you do so, you know, essentially your grade is going to be very, very low. Okay. You can submit, you know, solutions of low quality, and typically you'll see the assignments already have some of these solutions, and then you get a very low grade. Okay, and then you start submitting good quality solution, and we'll have a lower bar. Okay, so a standard that you have to meet to define what is a good quality solution. And it's going to be a reasonable algorithm, and your goal is to get at least to that level. Okay, or you can submit a really, really beautiful solution, and then you get the maximum grade. And so your goal is to be, you know, in between these two lines. Okay, so essentially that's what we hope you to do. Now, there is a thing which is really nice about this class is that you can submit solution over time, all over again, okay? So you can find your best solution, and then 2 days later, you have a better idea. You can, you know, run it again and submit it again, okay? And you can come back to assignments and resubmit. We'll talk about that. You can also use different solutions for different parts of the problems and submit them at the same time. You'll see how we can do that. But essentially, we give you a lot of freedom to actually get that grade as high as possible, okay? So time commitment typically is going to be 15 hours a week. Okay, so it's a tough class. Okay, so solving NP complete problems are hard. Okay, so you will have 1 or 3 hours to, you know, for the lectures, and you will have essentially 12 to 14 hours of coding. This is essentially for the later assignments. Okay, the assignments at the beginning are going to be a little bit easier. Okay, so there is a time investment in this class. Okay, so you have to be conscious of that, and you have to start early. You have to do these assignments, but of course, as I said, you can come back to them and revise them later on, okay? But there is a significant time commitment. It's not an easy class, okay? Now, as I said, the assignments remain open all the time. So the dates, there is a due date, which is a recommended completion, okay? So this is when we expect you to actually submit the assignment. Now, take this due date seriously because the assignments are going to pile up, okay? So you have one problem a week, okay? So if you accumulate 5 of them, that's a problem, okay? So especially given these things, okay? Then you will have a hard deadline. That's going to be the last chance for you to submit an assignment, okay? So, you know, you have to satisfy that deadline. But as I said before, you can always return to an assignment. You did it before the hard deadline, right? So you have a better idea, you take a shower, you get a really good idea, you come back, you code it, and then it's great. So you can submit a new solution and see, and we'll grade that one as well, okay? So we'll be always extremely fair in the sense that when we look at the solutions, we always will take the best of the solutions that you have submitted for any subset of the problems that you have submitted the solution for. So over time, your solutions, even if sometimes you submit a solution which is worse, it doesn't matter. We'll always take the best one, and you can have different techniques for different part of the assignments. And you can run them all the different techniques, and on the assignments, and we'll take the best one that you have submitted at any point. Okay? So really nice for you. Okay, now how to succeed in this class? Okay, so first thing you have to do is relax. Okay, be creative. Okay, and try to think about how to solve these problems. Okay, I'm going to tell you a story in a moment, but it has to be about learning and about solving these problems in practice. So one of the things that we want is for you to experience exponential growth. Okay, so we can talk about it for hours and hours, and then you don't have a feel about it. So what these assignments are for is for you to get a sense of what an NP hard problem is and what is exponential growth. Okay, so once you experience that, you will get some respects for these problems. And then you're going to start appreciating some of the techniques that we'll talk about. And you will see, oh, wow, these techniques are actually helping us really solve these problems, okay? And then you will also build intuition on which techniques are going to be, good for different kinds of problems, and which one you have to apply, and which one are easier to apply, which one are more complicated, but they will give you more benefits at the end, okay? So one of the things that this class will have is a lot of programming assignments, and you can get frustrated. And I want to tell you a story. When I was actually a young, student, a young PhD student, I had this great guy, Pierre Dufresne. And I came to him because I had this bug for 2 weeks. Okay, so 2 weeks I was building this optimization system, having a bug, and I couldn't find it. And so I went to him because he had a reputation of being a good debugger. And I asked him, what do I have to do? And he said, well, first, he told me, you are taking this wrong, okay? So you are getting frustrated. This is not what you should do. This is a game, you see. It's a game between man and machine, and man has to win, okay? And so we sat down and we had fun. We found the bug after about 3 or 4 hours, and it was a really learning experience. So you change your attitude, and then it changes the way you actually view the problems. So most of the problems that you will see in this class, you can view them as problem-solving, tricky puzzle, okay? And you don't have to get frustrated about them. You have to say, I want to beat this machine. I want to get these machines to do what I want, okay? So you'll see things like Sudoku, and one of the things you realize is that some of the techniques that we are actually using in this class will enable you to deduce most of the values here in a very, very simple manner, okay? And once you do that, these puzzles, they become much easier to solve. And many of the optimization problems that we'll see in this class, if you look at them in the right way, it's going to be really nice, you'll find really nice techniques to actually solve them. Okay? Now, there will be other ones that may seem completely messy, and you start by having something which is like looking like spaghetti code and so on. But one of the goals for you is also to try to make these things a work of art, okay? So solving optimization problems can lead to optimization problems that are truly beautiful. You will be really proud of them at the end, okay? So spend time finding solutions that are elegant, because most of the time, the elegant solutions are also going to be very efficient solutions and very effective solutions, okay? Now, there is a collaboration policy on this class. You have to take it very seriously. You can refer to the syllabus. The collaboration policy is spelled out in all the details. There are things that you can do, and there are things that you cannot do, okay? So we try to give you as much freedom as we can. There will be forum discussion, a lot of discussion on how to solve these problems. You can exchange information about solution ideas, okay? We'll let you do that. But you have to do that at a high level. It's like your personal life, right? So you can talk about it at a high level, but you don't want to enter into, intimate details, okay? You can share, the objective values, discuss some of these techniques, but, stay at a reasonable level, Okay? Now, there are things that we don't want you to do, so don't go on the web, find a cutting-edge research paper on the assignment and implement it, okay? So you will learn nothing, okay? Because essentially, you're going to take someone else's ideas, code them, and the only thing that you will have done is basically understanding that techniques, but you will not have understood what this class is all about, getting you to experience, what these problems are about, what is exponential growth, and how you have to be creative to actually solve these problems. Because most NP hard problems, okay, that you will encounter in practice are not the ones that you find in papers. Papers simplifies them. There are plenty of other constraints that you have in real life that typically are not in the papers that are written in academia. And for a good reason, because you don't want to describe the complexity of this world. But in practice, you will have to cope with them. So you have to experience what it means to solve an actual problem. And you have to get a feel of what's going to work, what's not going to work. That's why you don't want to do this. Don't go and implement something that somebody else has designed. Okay? The other things that we don't want is you to copy code from anyone else or to copy the algorithm of anyone else. Everything you use in this class should be your own. Okay? As I said, you can discuss the various approach. Okay? So we encourage that. Okay? Because in real life you can do that. Okay? But we want that the final solution be your own. It has to be your own algorithm. It has to be your own code. Okay? So have fun. Optimization is fun. The assignments are going to be fun. You're going to learn tons of things in this class. It's a lot of work. Okay? But it's also rewarding at the end when you see these things, generating very high quality solutions or proving optimalities to something that seems to be completely out of scope. Okay? So welcome again, and start working. Great.